medium is what is called denser, at that time refractive index will be greater than 1. Means refractive index of second medium with respect to the first medium is equal to velocity of first medium to the velocity of the second medium. Okay. So all of you know that here the refractive index of diamond is maximum. That is about 2.21 or 25, something like this. Okay, means the velocity of the light is least in diamond and velocity of light is maximum in the what is called as a vacuum, 3 into 10 raised to 8. Okay, so this is about what is called as a refractive index, absolute refractive index and relative refractive index. We can also find out in the 10th standard you have studied. So if you know the wavelength, velocity c is equal to frequency into wavelength. Velocity of light is equal to frequency into wavelength. When the light travels from one medium to another medium, frequency remains constant, but the wavelength changes. And so here we can write another formula for the what is called as refractive index. Eta 2 with respect to 1 is equal to lambda 1 upon lambda 2. Lambda 1 upon lambda 2. In this manner also we can find out the what is called as a refractive index. So refractive index काय सांगतं की एक मीडियम दुसऱ्या मीडियमच्या कंपॅरिझन मध्ये किती डेन्सर आहे हे दाखवणारी ती किंमत आहे. जेवढा जास्त रिफ्रॅक्टिव्ह इंडेक्स राहील तेवढा जास्त तो मीडियम डेन्सर आहे. रिफ्रॅक्टिव्ह इंडेक्सची व्हॅल्यू जेवढी कमी असणार तेवढी कमी डेन्सर तो मीडियम राहणार आहे. तर अशा पद्धतीनं with the help of the refractive index we can see how much the medium is denser with respect. More the denser, less will be the velocity. So we have the formula in the what is called as to find out the refractive index. 3 formulae are there. Number 1, eta is equal to sin I upon sin r. This is called as a Snell's law. Eta is equal to 2 with respect to 1, v1 upon v2. And third one, eta 2 with respect to 1 is equal to lambda 1 upon lambda 2. So these are the 3 formulas with the help of which we can find out the refractive index of one medium with respect to the another medium. Okay. So more the denser, less will be the velocity. And when the velocity will be less, wavelength is also less. Frequency remain constant. Frequency of the light is measured by the unit called as hertz. Okay. Wavelength is measured in the unit called as an angstrom unit. So 1 angstrom unit is equal to, all of you know, 10 raised to minus 10 meter. Visible light is having the wavelength ranging from 4000 or 3800 angstrom unit to the 7500 angstrom unit. More, the maximum wavelength is of the what is called as red, minimum wavelength is of the violet. Okay. तर अशा पद्धतीने we can find out the refractive index. Okay. So 2 types of refractive index, absolute refractive index and relative refractive index. Absolute refractive index is always greater than 1, whereas the relative may be less than 1 or greater than 1 depending upon the when the light travels from rarer to denser or denser to rarer. Okay. In the absolute refractive index, 1 number medium will be air or vacuum. Number 2 medium, lower medium will be of glass, water, diamond. The light, the medium through which the light passes is called as a transparent medium. Okay. So this they have given. Now illustration of the what is called as a refraction. You see that illustration of the refraction means illustration of refraction, that when you place a coin on in a bucket of water, that you see still water, you see the coin is coming upward. At that time, actually it won't come. The actual depth of the water is called as a real depth. And when the coin comes upward, we call it as the apparent depth. त्याला भास होतो आपल्याला वर आल्यासारखं, ते वर येत नाही. And so, in case of the pond or in case of the water, if you take a bucket of water, in that water, if you place a coin, the real depth upon apparent depth is also the refractive index of what is called as that water. So refractive index of water is equal to a real depth upon apparent depth. Using this formula also we can find out the refractive index of water. Or if you take a glass slab, if you make on a white paper, if you make a ink spot, and over that ink spot, if you keep the glass slab, the spot appear to be coming upwards. So when it appear to be coming upward, that is called as the apparent depth. When it is at the bottom, that is called the real depth. The ratio of the real depth to the apparent depth is also called as the refractive index. Means fourth formula of the refractive index. Eta is equal to sin I upon sin R, eta is equal to V1 upon V2, eta is equal to lambda 1 upon lambda 2. One more formula for the refractive index is equal to eta is equal to a real depth upon apparent depth. Okay. Now here, if this is the formula for the real depth and apparent depth, they have given one example. How this formula comes? That formula, a real depth upon apparent depth, that we'll see in the next period, that formula. But remember that here, when the light travels from one medium to another medium, velocity and wavelength changes, frequency remain constant. When light travel from what is called as a rarer to denser, its velocity and wavelength decreases. And when light travel from denser to rarer, its velocity and wavelength increases. So using these formulas, we are able to find out how one medium is denser with respect to the another medium. Okay, how one medium is denser with respect to the another medium. Okay, so what we have seen today, we have seen first of all the spherical aberrations, why the spherical aberration causes, and how to reduce the spherical aberrations. And that formula, F is equal to R by 2 and 1 by F is equal to 1 by V plus 1 by U, they are holds good only for the what is called as a rays which are close to the principal axis. To reduce the aberrations, we have to take, instead of what is called as a spherical mirror, we have to take the parabolic mirror so that the aberrations can be reduced. Okay, so we'll stop here. In the next week, we'll see how this formula comes. Eta is equal to real depth upon apparent depth. The refractive index eta is equal to real depth upon apparent depth. Okay, so today I am taking this lecture with the help of the video recording because I am out of station. In the next week, I will take the live class. Okay, thank you.